Hello everyone, this is Anishu and in this video we will learn about I2C communication with Raspberry Pi and different sensors.
Before diving further into this project, let us learn what is I2C. I2C or Inter-Integrated Circuit is a popular communication protocol used for connecting multiple electronic components on the same circuit board. It is widely used in embedded systems, including Raspberry Pi, to enable communication between various hardware modules. So, the library that we will be using in this project is SMBus2 library. It is an exceptional library that allows us to work with I2C devices on a Raspberry Pi. You can learn more about SMBus library and SMBus2 library by simply searching them over the internet. You can check the documentation and see how various functions are utilized in this library. Now, how we will be utilizing this library in the code. The first step that we will be doing is we will be using the SMBus2 library to initialize an I2C bus. We do this with the smbus2.smbus function, specifying the bus number. For most of Raspberry Pi models, it is either 0 or 1. This initialized bus allows us to communicate with I2C devices connected to the Pi's GPIO pins. With I2C bus initialized, we can use SMBus2 functions to read the data from the connected I2C devices. Some of the common functions are read I2C block data that contains the parameter address, register and length. It reads a block of data from the device with specified address. The address parameter represents the I2C address of the device we want to communicate with. The register parameter defines the starting register where we want to read the data, and the length parameter tells the library how many bytes of data to read. There are other functions like write I2C block data, which contains similar parameters. In conclusion, the SMBus2 library is a powerful tool for enhancing I2C communication on the Raspberry Pi. It simplifies the process of reading and writing the data to I2C devices, making it accessible to Python programmers. Whether you are working with sensors, displays, or other I2C peripherals, SMBus2 can help you easily interface with them in your projects.
Since SMBus2 is a new version of the SMBus library, we need to install it first before using it in our code. To install it, we can simply write the command pip install SMBus2 in the terminal and press enter. Then we can install it. I have already installed it in my Raspberry Pi.
It is time for the code explanation for this project. Let's start by importing the necessary libraries. We are using SMBus2 to communicate with the light sensor over I2C and the time library for timing functions. Next, we define a function called readLightSensor. This function does the heavy lifting of receiving the data from the light sensor. It initializes an I2C bus and reads 16 bytes of data from the sensor, starting at a specific register. The raw sensor value is calculated by combining the 2 bytes of data read from the sensor. Then we calculate the lux value by dividing the raw value by 1.2 and routing it to 2 decimal places. This is the actual light intensity measurement. The lux value is returned to the calling code. Moving on, we have a function called classify light intensity. This function takes the lux value as input and classifies the light intensity into different categories. For example, if the lux value is less than 10, it is classified as too dark. If it is between 10 and 50, it is classified as dark, and so on. This function allows us to interpret the lux value in a more meaningful way. Before we start reading the sensor data, we print some introductory messages to the console, providing context for what the code does. Now, the heart of the script is the continuous loop that runs indefinitely. In each iteration of the loop, we call the readLightSensor function to get the lux value from the sensor. Then we call classify light intensity function to determine the light intensity category. We print the lux value and the corresponding intensity to the console. To avoid continuous and rapid readings, we introduce a 1 second delay between readings using time sleep 1. So there you have it. With this, the code explanation for this project ends. Finally, it is time for the demo. Before diving into the hardware demo, let's understand the circuit diagram. As you know, the SDA and SCL pin of the Raspberry Pi belongs to the GPIO2 and GPIO3 respectively. So we will connect our BH1750 sensor to the Raspberry Pi through the GPIO2 and 3 pins, that is the SDA and SCL pins. We will also connect the VCC and the ground pins to give the power to the light sensor. As I increase the intensity of light, the lux readings from the sensor increases significantly. At the same time, the intensity shows different prompts accordingly to the lux values. With decrease in intensity of light, the lux value decreases significantly and the prompts are also changed. With that, the demonstration is complete. I hope you enjoyed the video. Thank you.